Invariant means that it doesn't move. It stays the same as where it is, or this coordinate doesn't change. It's enlarged, so it's getting bigger or getting smaller from centre B. The scale factor here is actually irrelevant. It doesn't matter what the scale factor is, it would always be the same point, which is invariant. If in doubt of how scaling works, think about how you use a touchscreen. So if I was to scale from this point, and I was to put my finger here and put my finger here, and I was to scale away from that point, then we can see that B isn't moving. The rest of the points are going off the screen. So it must be B, which is invariant. When you're scaling, it follows these kind of lines. So it's scaling along these lines, going through the corners. And because all the lines meet at B, then it must mean it's B, which isn't moving. Don't be thrown off by the diagram here, because it's not drawn accurately. If you were to just think, y equals x, that's a diagonal line going up, then none of the points lie in there. They're all going to get reflected, they're all going to move. But it's not quite drawn accurately. And if y is equal to x, that must be this point here, where 1 is equal to 1. The line must go through that point there. And if a point lies on the line of refraction, then it's not going to move, because it hasn't got any distance. Q is obviously going to reflect, because it's further away. It's going to appear somewhere over here. S would appear somewhere down here. Now, I can't actually draw on what it would look like, because it's not drawn accurately. The proportions aren't quite correct between the x and the y. But we get the point P. That must be the one which doesn't move.